Hello. In this section, we discuss numerical methods. Numerical methods are very important in engineering because some of the problems in engineering are difficult to solve by using analytical methods. In that case, we use numerical methods. Here we discuss mainly three topics. One is to find solutions of functions or root of equations by using numerical method. Second is to find value in between a range of values, that is called interpolation. That is, we examine situation for some case like time equal to 1 minute, 2 minute, 3 minute, 4 minute, etc. But we intend to find value for 1.5 minute. In that case, we use interpolation. Next is to find solutions of definite integral, that is, a limit is given and integral we need to evaluate, and we are not using the traditional analytical method, but we use different kind of method to solve the function and integrate that function over a limit. Okay, now we will discuss the method for finding solutions of function or root of an equation by using fixed point iteration method. In this case, a function is given. For example, an equation is given, f of x equal to 0. We need to find the solution for that equation. To find this solution by using this method, we rewrite the equation as x equal to g of x in the form of x equal to g of x, and we say xn plus 1 is equal to g of xn for n greater than or equal to 0. Then we solve. Also, we take a initial value to solve the equation. So the idea is we first of all write x in the form of x equal to g of x. The solution of function is the point where it touches the axis. You can see the point C here. An important theorem, intermediate value theorem, it says that a function has continuous in a closed interval AB and satisfies for some point and gives value positive, and for some other point has value negative, and we can immediately say that there is a root, a real root in between interval AB. So when we are going to search a solution for the equation, we try to find whether it coming from or it starts from a positive value and go to negative value, or in other words, it starts from a negative value and crosses to positive value. We say that it may touch the axis in between somewhere. So that is, if it starts from a positive value and crosses the axis, and then only it go to negative value. So we say that it is having a root, a real root in between. So to get the first clue about the root, we substitute values and we try to find the change from positive to negative, and we can say that the root is in between that range when it changes the sign. Okay, the positive sign to negatives or negative sign to positive, we can say that the root is in between somewhere, and we start the iteration by using the either the value which start from negative to positive or positive to negative. Usually when you solve a particular function, a quadratic equation, graphically you can say that the point where it touches the axis is the solution. That means here you can see the blue curve which touches point 2 and 3. Also when solve this equation, you get the solution is 2 and 3. So that is a concept. So before 2 it were positive value, and after 2 you can see it is having negative value, and before 3 you can say that it is having negative value, and after 3 it is having positive value. For this case we can say that when you substitute values from 1 to 2.5, you can say it crosses it having positive value and it gradually develops to negative value, and you can say that, say, the root is in between 1 and 2.5, and you can take x0 as either 1 or 2.5 and then go for iteration. Finally it will go to value 2. As I said in the previous slide, whenever you get f of x equal to 0 kind of function, you convert that function to x equal to g of x form. For in this example, x square minus 5x plus 6 can be converted as x equal to 1 by 5 into x square plus 6. Graphically, we say that we take these two functions, we take x equal to f of x, and the other side g of x is equal to 1 by 5 into x square plus 6. When you plot these two, the point where these two touches is the solution. We take that in that sense in the graphical way. So you can start with any point. Finally, it after iteration, it will go to that value called 2. You can clearly see in this equation, the blue indicates the curve 1 by 5 into x square plus 6. The red indicate f of x equal to x. So finally, when you touch this line, you get the solution. Again, you can start with any value of x0, but if you take x0 very closer to the real answer, the iteration will be less. You can with less steps we can reach to the value. But in the previous case, we say that in the function is positive and negative, we can take any value near to that solution and you can start iteration. Also, to check convergent point, you can also take when you convert x equal to g of x form, you can take g dash x and check whether mod g dash x is less than or equal to a constant or less than 1. Okay, then we can say that it converges to a particular point. Now let us try to solve one equation, or to find a root of an equation. Cos x is equal to 3x minus 1. To solve this, first of all, let's take f of x equal to cos x minus 3x plus 1. Now we try to find the behavior of the function from whether it is fluctuating or converting from positive to negative value. So substituting different values, we start with usually with 0 and substitute different values for the function. Here we can clearly say that for substituting 0 it get positive value, and substituting pi by 2 you are getting negative value, and we can say that root is somewhere in between 0 and pi by 2. Okay, so this is the first clue of the root. Now we rewrite the equation to x equal to g of x form. Now we can convert this into iteration equation. Xn plus 1 is equal to 1 by 3 into 1 plus cos xn. So this can be used for iterative method. Then to check whether this converges, we take g of x is equal to 1 by 3 into 1 plus cos x, and we find g dash x, and modulus of g dash x we try to find, and in that interval we say that it is definitely less than 1. So we can say that this root exists and converges, and we can now go to iteration. Now we can start with x not equal to 0, and the iteration equation xn plus 1 is equal to 1 by 3 into 1 plus cos xn. Okay, so when you substitute n equal to 0, we get x1 is equal to 1 by 3 into 1 plus cos x naught. So we substitute x naught is equal to 0, we get equal to 1 by 3 into 1 plus cos 0 equal to 0.667. Now we substitute different values for n, and we get x1, x2, etc. So for n equal to 1, we get x2 equal to 1 by 3 into 1 plus cos x1. We received x1 from the previous step and we substitute values, we get x2, and then we write n equal to 2, then we get x3 equal to 1 by 3 into 1 plus cos x2. So 1 by 3 into 1 plus x2 is received from the previous step. So we use that, we get x3. Continuing like this, we get values for x, different x. When you go further forward, you can observe that for the each step you are getting a value very closer. That means you go to precise value for x. That will work for the function. Okay, so sometimes the question will be asked for finding up to 3 precision. You can stop the process after getting up to 3 precision value. So continue until what precision you need to get. So we can wind up after that iteration step. Now let's see another question. Solve x cube minus sin x minus 1 equals 0 by using fixed point iteration method up to 2 decimal places. Here first of all we need to find the range or the broad interval of the root, so that we substitute different values 0, 1, 2, etc. Okay, so we need to find whether positive value goes to negative or negative value goes to positive. In another sense, we can also say that whether multiplication of these two values become negative. It happens only when one of the value is negative. Okay, so for that you just multiply these two values and get, if you get negative, you can say that the value or the root of equation lies between these two input, that is here 1 and 2. Now rewrite the equation as x equal to g of x form, and then you try to find g dash of x, and here clearly mod g dash of x is less than 1 in between 1 and 2. So we can say that we have root, we have a real root in between these two intervals. Since we have this function x cube minus sin x minus 1 is equal to 0, and we can convert that into x equal to 1 plus sin x power 1 by 3, and the iteration formula becomes xn plus 1 is equal to 1 plus sin xn power 1 by 3. Here we see that we take the left hand side as n plus 1th term, and the right hand side whatever comes with x we take nth term. Now as usual we start with x naught, but we here received in between 1 and 2. For a change, let us take x naught equal to 1.5, and we start with the iteration equation. We substitute n equal to 0, we get x1 is equal to 1 plus sin 1.5 per 1 by 3. Here you must take the value, sin value as radian, not like degree. If it is degree, like in the previous case pi by 2 like value are received, you can take as degree, but here you must take as a radian. Okay, so finally we get values for the different x, x2, x3, etc. So up to 2 decimal places we can stop from x4 because we are getting 1.44. So up to 2 precision it is fixed, so you can stop the iteration here. For this function, if you go further forward with some more iteration, we'll get more precise value, but up to maybe 4 steps it is okay. So graphically you can say that it is coming closer to that value, and finally it reaches to the particular point. Now let us discuss another method which is called Newton's method or Newton-Raphson method. This can also be used for finding solutions of function or root of function, and the method for finding this is, the iterative equation is xn plus 1 is equal to xn minus function of xn divided by derivative of that function at xn. Here also you need to find the approximate solution range by using the previous method, whether it coming from positive value to negative value, etc. That same method can be used for the initial value and go further forward. Now let us solve equation x raised to 4 minus x minus 7 equal to 0 by using Newton-Raphson method. For this, we first of all take that as a function f of x equal to x raised to 4 minus x minus 7 equal to 0. Then you substitute different values. You can clearly say that say for f of 1 equal to minus 1 and the f of 2 equal to 5. So we can say that the values in between 1 and 2, or you can just multiply minus 7 into 5, which becomes less than 0, and we can say that by intermediate value theorem, root is in between 1 and 2. Okay, so next we will use the equation to get iterative values or different values for x iteratively. So we find that in the values in between 1 and 2, now you take x naught is equal to 1.5 as initial guess. So then x1 becomes, when you put n equal to 0 in the master equation, x1 is equal to x naught minus f of x naught divided by f dash x naught. We have x naught is equal to 1.5, then you substitute that, we will get answer as 1.78541. Now you take n equal to 1, then you get x2 is equal to x1 minus f of x1 divided by f dash x1. So x1 is received in the previous step, you substitute that, finally you get x2. Proceeding like this, you get x3 and x4, etc. Okay, so here up to 6 decimal places you get the value. You can also use this method for finding root of a particular number, square root of a particular number. For example, you take square root of c, applying c equal to 2. Here we substitute first of all x equal to root c, then you square, that means x square equal to c, then you take that as a function f of x equal to x square minus c equal to 0, then you get f dash x is equal to 2x, and finally you can convert that into the master iteration formula, xn plus 1 is equal to xn minus f of xn divided by f dash xn. Substituting, you will get the value. So here in the question, if it is asked to find for c equal to 2, you can take c equal to 2 and substitute value for that. Now we can take any value, suppose x naught is equal to 1, we obtain values for different x1, x2, x3, etc. So finally, up to what precision you can stop the equation. Also you can solve different kind of equation, like find value for 24 power 1 by 3 using Newton-Raphson method. In that case, you take x is equal to 24 power 1 by 3, that means x cube becomes 24. Then you rearrange that, x cube minus 24 equal to 0, then you get an equation. So take f of x equal to x cube minus 24. So you proceed like in the earlier step, like the master formula xn plus 1 is equal to xn minus f of xn divided by f dash xn. Now let us discuss another important numerical method, which is called interpolation. Often it is also called Lagrange interpolation. So the method interpolation is nothing but estimation of new data points from existing given range of discrete set of known data points. That is, so if you are given with some data points, you can find the in-between value by using this method. So this is called interpolation. So consider the situation, we are measuring height of a plant in day 1, 3, 5, 7 and 9. Suppose that we need to find the height of that plant approximately in day 2. Okay, so in that case we are using interpolation. In day 2 we didn't taken the reading, but we can interpolate the result to find value at day 2. In the Lagrange interpolation method, here the difference between days are same, but in Lagrange interpolation method we can use or we can find with unequal intervals in x limit, x values. Okay, in this method we first make a polynomial Pn of x by using the equation. You need to keep in mind of this equation. That means it is very easy to make the equation. First of all, in the numerator you exempt x naught and subtract with x. The whole values should be subtracted with x. And in the denominator, whichever is eliminated or exempted, you take that value. Here we eliminated or exempted x0. You take difference with the other values, that is x0 minus x1, x0 minus x2, x0 minus xn into y0. The next term is, you first of all you exempted x0, now you exempt x1. So x minus x0, not x1, x minus x2 and up to x minus xn. So since we exempted x1, take in the denominator x1 minus all other values, x0, x1 minus x2, x1 minus x1, xn. So into y1. Like this way you make different terms up to what y terms are there. You take terms and then you make a polynomial like this. Let us consider an example. So in this example it is asked to find value of y at x equal to 0, but it is not in the reading. See, in the reading x equal to 5, 6, 9 and 11 are given. Here clearly it is unequal interval. So first of all 5, 6, then 9, then 11. So you can use Lagrange method here. So we need to find for x equal to 10 what is the value of y. So first of all you construct the polynomial by using the previous method, that polynomial construction method. So here y0, y1, y2, y3 are there. So there are 4 terms in the polynomial. So construct the polynomial first. So here in the slide we have constructed the polynomial. See in this slide. Okay. Here we are asked to calculate value for x equal to 10. Now you substitute x equal to 10 this polynomial. So after calculation we get it is equal to 14.6. Okay. So this is a method for finding value in between a particular range if unequal intervals are given, for unequal intervals of x. Another interpolation method is Newton's interpolation method. It has two different variants. One is Newton's forward interpolation and Newton's backward interpolation method. Here we take several terms like first forward difference, second forward difference, third forward difference, etc. First forward difference are the values received from difference of each and every consecutive terms in the raw data. Then after, when you get first forward difference, when you subtract in between first forward difference, you get second forward difference, and so on. Finally, the formula is y of x is equal to y0 plus u into delta y0 plus u into u minus 1 by 2 factorial into delta square y0, u into u minus 1 into u minus 2 divided by 3 factorial into delta square y0, etc. where u is equal to x minus x0 divided by x. For more clarity, let's solve this problem. For the following data, calculate value for y when x equal to 9. This forward method is used for finding value near x0. See here x0 is 8, x1 is 10, x2 is 12, x3 is 14, x4 is 16, x5 is 18. Similarly, y0 is 10, y1 is 19, y2 is 32.5, y3 is 54, y4 is 89.5, y5 is 154. Now make this as a table. So we here find first forward difference and second forward difference, etc. up to it end up with a value. The first forward difference is obtained by subtracting the consecutive terms of y. Here say y1 minus y0, that is 19 minus 10 gives 9. Similarly 32.5 minus 19 gives 13.5, etc. Second forward difference is obtained by subtracting the consecutive terms, that is the nearby terms. We get 13.5 minus 9, we get 4.5, 21.5 minus 13.5, we get 8, 35.5 minus 21.5, we get 14, 64.5 minus 35.5, we get 29. Now repeat the procedure to get next level. Again go forward with the same procedure. Finally you end up with a 1 value. You can find u. U is nothing but x minus x naught divided by h. H is the interval length of x. Okay, so here it is asked to find x equal to 9, value for y at x equal to 9. So x is equal to, we substitute as 9, and x naught as our x naught value 8 divided by interval width, that is interval width is here 2. So we get u as 0.5. Now you can apply the formula, see the figure, see the picture, and identify delta y naught, delta square y naught, delta cube y naught, delta raised to 4 y naught, delta raised to 5 y naught. So this is used, this notion is used for finding interpolation near x naught, that is forward interpolation method. Also you be very careful about the formula. It is u into u minus 1. We will discuss another formula in the coming session for the backward interpolation method. So be very sure about this formula. So you identify delta y naught, delta square y naught, delta cube y naught, delta raised to 4 y naught, etc. Now you received all the ingredients for the formula. So since we have up to delta raised to 5 y naught, we stop there. So using this formula, substitute values from the table. Finally we get value as 14.2323. Now let us look at Newton's backward interpolation formula. It is very similar to the previous case, but small difference is there in formula, also the notation. In this backward difference is used for calculating formula. Here the reversed operator, delta operator, we call it as del. Del is used for identifying it is backward interpolation. Also instead of y naught we take it as y1. Okay, y1, y2, etc. Okay, so here we first calculate the backward difference and then we calculate second backward difference. After you get all backward differences, you can calculate the value by using Newton's backward interpolation formula. It is given like this way. Also take care that instead of u, we are using v here. V is equal to, in earlier case, as in earlier case, v is equal to x minus xn divided by difference, that means h. And here also small difference is there. In the previous case we used u into u minus 1, but here v into v plus 1 is used for each coefficients. Okay, so please take care of this formula, and until you get the final differences like del raised to 4 or del raised to 5, etc. When you stop there, you can stop using the coefficients numbers. So finally you get the answer in the previous case. Now let us consider a problem. Use the following data to calculate value for 1996. So the population survey is given, maybe in lakhs or crores. So here we need to find a value for 1996, but the reading was not taken in 1996. Okay, but the interval is having equal width, 61, 71, 81, 91, 2001. So we can use Newton's formula. So it is also near xn, I mean yn. Okay, we need to calculate the value near xn, that is near 2001. So we can use the Newton's backward interpolation formula. If it is near 1961, we can use forward interpolation formula. So near x naught we use forward, near xn we use backward. Okay, as in the previous case, you find the differences. Okay, here y1 minus y naught, etc., etc. You find the difference of each and every consecutive values. Now you carefully repeat the procedure and find differences and write in the next column. Again you find the backward differences. That means you find the difference of each and every consecutive terms and write in the next column. Finally you come up to a point, a single point where you can stop the procedure. Now you can calculate value for v. V is equal to x minus xn divided by h. We are required to find value for 1996, so x is equal to 1996, xn is equal to 2001 divided by h. H is the difference or height or interval, so it is 10. So after all we get v is equal to minus 0.5. Now we can identify the values for the formula. Since we are using Newton's backward interpolation, we write in terms of yn, here y4. So we identify del y4, del square y4, del cube y4, del rest of y4. So you can straight away apply to the formula. In the formula, you just have a look at the formula. y4 plus we are using, instead of y0 here using y4 here, y4 plus v into del y4 plus v into v plus 1 divided by 2 factor into del square y4 plus v into v plus 1 into v plus 2 divided by 3 factor into del cube y4 plus v into v plus 1 into v plus 2 into v plus 3 divided by 4 factor into del cube y4. Now you apply the values for this particular formula. Since we have y4 is equal to 101 and v is equal to minus 0.5, and we can substitute each and every terms. So finally what we get is 97.67. So we found that for if this is the trend, the value for 1996 will be 97.67. Now let us proceed to numerical integration. Numerical integration is method to find value for definite integral, that is area under the curve from a particular value interval a to b. Okay, for this we are not doing in the way where we do in algebraically. We are using a different method to solve the definite integral. We have two methods, one is trapezoidal rule and Simpson's rule. In both of this method we divide the interval from a to b into different sections and we name as x0, x1, etc., xn minus 1, xn. Okay, actually x0 is a and xn is b, so we represent this into different sub intervals or small intervals, and then we calculate area for each and every part and then we sum that. This is the concept. Using trapezoidal rule, integral a to b f of x dx is given by x by 2 into y0 plus yn plus 2 into y1 plus y2 plus etc. yn minus 1. That is, we take h by 2 where h is equal to b minus a divided by n. That means starting point minus end point divided by number of parts. Okay, so h by 2 into y0 plus yn plus 2 times all other terms. Okay, 2 times all other terms. So using this you can approximately find value under the curve y equal to f of x from a to b. For example, let us find integral minus 3 to 3 x raised to 4 dx using trapezoidal rule. So here what we need to do is we just need to substitute different values from minus 3 to 3 for this particular function. Okay, but here for simplicity we are taking interval as 1. So minus 3, minus 2, minus 1, 0, 1, 2, 3. These are the values for x. Then you substitute to find y equal to x raised to 4, and then you write all the values for y equal to x raised to 4, and now you get y0, y1, y2, etc. Okay, the terms. So the trapezoidal rule states that integral a to b f of x dx is equal to h by 2 into y0 plus yn plus 2 times y1, y2, etc. yn minus 1. So here you can take the same thing and you can say that here the b minus a 3 minus minus 3, that is 3 plus 3, that is 6. Okay, n equal to 6. So you can calculate h is equal to b minus a divided by n. That means 3 minus minus 3 divided by 6 equal to 1. So h equal to 1. So now you can substitute in the formula. So integral minus 3 to 3 x raised to 4 ds is equal to h by 2, 1 by 2 into first term and last term, 81 plus 81 plus 2 times all other terms, which gives 115. Okay, in this way you can do any integral of any function. You can take interval difference as 1 if nothing is given, otherwise it will be given in the question. Now next way is Simpson's 1/3 rule. It is similar to the previous one, but the formula is bit different. So it takes h by 3 into y0 plus yn, first term and last term of y, plus 4 times odd term plus 2 times all even term. In the similar way you can use Simpson's rule to find integral minus 3 to 3 x raised to 4 dx. So here x0 is equal to minus 3, xn is equal to 3. The interval is divided into one difference. So finally you can use the formula we previously calculated as h is equal to 1 and n is equal to 6. So 1 by 3 into first term plus last term, 81 plus 81 plus 4 times all odd terms plus 2 times even terms, which gives 98. So Simpson's rules gives some more accurate result than the trapezoidal rule. Now let us see a numerical method to solve initial value problem, that is a differential equation with an initial condition. Okay, so first of all we study Euler's method for solving initial value problem. In this we take an x0 initial value which are given in the problem itself. So then you calculate x1, x2, etc. x1 is x0 plus a increment h, and x2 is and again x1 plus an increment h, etc. Then yn plus 1 is equal to yn, okay, yn plus h into function of x and yn. That is the formula. So yn plus 1 is equal to yn plus h into function of x and yn. So we calculate for different n values, then you get the answer. For more clarity, let us see an example. Find a solution of differential equation y dash is equal to 2xy plus 1 with the condition y of 0 equal to 0 and h is equal to 0.02. Here x0, from the initial condition we can understand that x0 is equal to 0 and y0 is equal to 0, because y of 0 equal to 0, x0 is equal to 0 and y0 is equal to 0. And the function we can take y dash is equal to f of xy, compare with y dash is equal to f of xy, then f of xy is equal to 2xy plus 1. For step 1, n is equal to 0, we can say that x1 is equal to x0 plus h. So since x0 is 0 and h is equal to 0.02 given, so at x1 we keep a 0.02. Now let us use the formula yn plus 1 is equal to yn plus h into function of x and yn. So y put n equal to 0, y1 is equal to y0 plus h into function of x0 y0. So y1 is equal to, actually y1 is what, y of x1, okay, y of 0.02 equal to, what is y0, 0, 0 plus and h is equal to 0.02, 02 into f of 0, 0, that is 0 plus 0.02 into, you apply that function f of xy we have rewritten as a function, right? In that you apply 0, 0. So we get answer as y1 as 0.02. Now you proceed, since we have received x1 is equal to 0.02, and in the previous step we have calculated y1 as 0.02. Now you can calculate x2. x2 is equal to x1 plus h, which is equal to 0.04. Then y2 is equal to y1 plus h into f of x1 y1. Okay. So y2 is equal to y1 plus y1 is calculated in the previous step plus 0.02 into function of 0.02. So x1 y1. So you apply a function of 0.0202 and that earlier function f of xy equal to 2xy plus 1. So finally you get y2. Now we have received x0, y0, x1, y1, x2, y2. You can readily calculate x3 by considering x3 equal to x2 plus h equal to 0.04 plus 0.02 equal to 0.06. Now you can calculate y3 is equal to y2 plus h into function of x2, y2. So y3 is equal to y2 we calculated in the previous step 0.04 plus h is equal to 0.02 into function of 0.02, 0.02. You apply in that function 0.02, 0.02 for x and y values, you get y3. So now you have x0, y0, x1, y1, x2, y2, x3, y3. Now you can calculate y4. We have x4 is equal to x3 plus h equal to 0.6 plus 0.02, 0.06 plus 0.02 equal to 0.08. Now you apply the iteration formula. y4 is equal to y3 plus h into function of x3, y3. So y4 is equal to y3 we have in the previous step 0.06 plus 0.02 into function of 0.06, 0.06. So we get 0.08. Now proceed for the next step. x4 we have x4 is equal to 0.08 and y4 is equal to 0.08. x5 we can calculate x4 plus h. So y5 is equal to y4 plus h into function of x4, y4. We get y5 is equal to 0.01. Actually y5 is equal to y of x5, right? Y of x5. Since x5 is equal to 0.01, so y of 0.01 is equal to y5 is equal to 0.01. Sometimes the question will be asked for finding y of 0.01. In that case, you imagine or think that y of some x value. So 0.1 is some x value. You iterate the step until you get that x value as 0.1. Okay. Next is another method, Runge-Kutta method for finding solution for differential equation with the initial value. So here also we can have x1, x2, etc. by x1 is equal to x0 plus h, x2 is equal to x1 plus h, etc. And we have different formula for finding Runge-Kutta method. Here we are using fourth order Runge-Kutta method. For that we have four intermediate constant k1, k2, k3, k4, which is given in the slide. We just study that formula. K1 is equal to h into function of x and yn. K2 is equal to h into function of x n plus h by 2 y n plus k1 by 2. Okay, k1 by 2. K3 is equal to hf into xn plus h by 2, comma yn plus k2 by 2. Here k2 by 2. So listen that k4 is equal to hf into xn plus h, comma yn plus k3. Here the up to I mean from k2 onwards in the second parenthesis term is using previous kth term. Okay, that is depending on the previous result. So here you can say yn k2 yn plus k1 by 2, k3 the second tuple term is second term in tuple is yn plus k2 by 2. Okay, listen that and read that carefully. Then now yn plus 1 is calculated as yn plus 1 is equal to yn plus 1 by 6 into k1 plus 2 k2 plus 2 k3 plus k4. Let us solve a problem using Runge-Kutta method with h is equal to 0.1. Find y of 0.2 given that dy by dx is equal to e raised to x plus y with a y of 0 equal to 0. So in that case you take f of xy is equal to e raised to x plus y. from the question itself, initial value is given, y of 0 equal to 0. So x0 is equal to 0 and y0 is equal to 0. So since h is given in the problem question itself, so x1 is equal to x0 plus h is equal to 0 plus 0.1 equal to 0.1. We can find intermediate value k1, k2, k3, k4, etc. k1 is h into function of x0, y0, that is 0.1 into, you apply x0, y0 in the function, which get here is 0. So finally we get k1 is equal to 0.1. k2 is equal to hf into h into function of xn plus h by 2 comma yn plus k1 by 2. Okay, here but we are using the first iteration, so we can say that it is instead of xn, k you can use x0. So k2 is equal to h into function of x0 plus h by 2 y0 plus k1 by 2 is equal to 0.1 into function of x0 is 0, 0 plus h by 2 is 0.1 by 2 comma y0 is 0 and k1 is 0.1 by 2. So finally you get k2. Similarly you can find k3 h into function of x0 plus h by 2 comma y0 plus k2 by 2. So we get k3. k4 is equal to h into function of x0 plus h comma y0 plus k3. You get that value. Now y1 is equal to y of x1 is equal to y of 0.1 equal to y0 plus f the formula 1 by 6 k1 plus 2k2 plus 2k3 plus k4. So finally we get the result for and that question. Okay, this is all for now. Please consider to do more problems on each topic. This is particularly numerical concept chapter, so you need to get familiar with more problems, then only you can understand the concept and do it in the exam point of view. Okay, so I have given notes and materials in that you have more and more problems. Try to do that and familiarize with each and every problems.